the side of my leg. He's like, oh my God, you got a compound fracture. I'm like, fine, I can still walk. I'm like, it's just a bad cut. It was hung about that wide. It was about, I don't know, when I move my leg up and down, I can see my muscle moving. Yeah, they only gave me 9. I couldn't believe it. I said, come on, they only gave me 9 stitches.
Good morning.
He said it don't matter. And the leg feels different.
For today we did 1 through 24, every third one. This is on page 367. So starting with number 1, the answer should be 4x minus y equals a negative 5. Try to remember to do it before I come. Okay, number 1 should be 4x minus y equals negative 5. And then number 4 would be 3x plus y equals 10. 3x plus y equals 10. Number 7, 3x plus 5y equals negative 2. Number 10, 3x minus y equals 0. Then 13 is 2x minus y equals 1. 16, 3x plus y equals a negative 3. 19, x plus 2y equals 6. 22, 3x plus 7y equals 8. And that's it? Yep, 22, 3x plus 7y equals 8. And we didn't do 24 then because we'd end at 22. Then we start with 34. And 34 is parallel. 37 is perpendicular. And 40 is perpendicular. Then 43 would be 2x minus 15y equals a negative 120. 46, 13x plus 5y equals 37. 49, 5x minus y equals 4. 52, 3x plus 4y equals a negative 12. 55, y equals 2. 58, x minus 3y equals a negative 1. And 61, 5x plus y equals 3.
Number 52, 55.
46, please.
Okay, we'll start with number 52.
Could you do 22 also, please?
Okay, number 52 says parallel to line 3x plus 4y equals negative 9. Y-intercept is 0, negative 3. Or you can say 0.0, negative 3. It doesn't matter. What we need is a slope and a point, either the y-intercept or any other point. And what we would need to do then is find the slope of this line. If we want it parallel to this line, what do we know about its slope? Has to be the same, right? To find the slope of a line, you put it in slope-intercept form. So the first thing I'm going to do is subtract 3x from both sides to get the y by itself, because slope-intercept form is y equals something. Then we divide everything by 4. So we'd have y equals a negative 3/4 x minus 9/4. And I don't even care about the minus 9/4 because what I'm looking for is the slope. The slope's right here of this line. If I want it parallel to that line, it'll have the same slope. So then I'm going to find the line that has the slope of a negative 3/4 and the y-intercept 0, negative 3. Okay? So in other words, you had to take this line and put it in slope-intercept form to find its slope. If you want it parallel to it, it should have the same slope. You can put it in either of the forms then, but if it's the y-intercept, I may as well put it in this one. It would also be correct if you put it into this one. It doesn't matter which one you use, actually.
That one there seemed easier for some
This
reason.
one or this one?
The second.
Okay. It makes no difference. It's up to you which one you put it in. When I put it in this one, now I thought in this case this one would probably be easier because it's going to be a negative 3/4 x minus 3. Now I would multiply through, because we need it in general form in the end, get rid of the fraction. I'll do it in both and just show you. And so I'd multiply by 4. And 4 times everything on this side. But using the distributive property, then it's going to look like that. So I'm just going to use the distributive property and take the 4 times each term right away instead of writing it down twice. This would cross out. And now I just add 3x to both sides, because general form is ax plus by equals c. And I'd have the equation 3x plus 4y equals a negative 12. Okay, now he felt it was easier putting it in here, so let's put it in here. We'd be y minus, and y is negative 3 equals, and m was a negative 3/4 times the quantity x minus 0, right? If I chose to put it in this one, y is negative 3, x is 0, and the slope is still negative 3/4. So here I'd have y plus 3 equals a negative 3/4 x, because a negative 3/4 times 0 would be 0, so I don't have to write it down. Now, once again, multiply by 4. I'd still multiply both sides by 4, but this side has 2 terms, so I'm going to use the distributive property right away and say 4 times that one, 4 times this one, and 4 times this one. And so we'd have 4y plus 12 equals negative 3x. Now, what did you do next? Move the x, move the 12, move the y, whatever. It's your choice. Okay, so add 3x to both sides. Then I'd have 3x plus 4y plus 12 equals 0. Then I'd have to move the 12, right? You could do it in the same step if you wanted to. Answer 3x plus 4y equals negative 12. Did we get the same answer either way? Yep. It's totally your choice which one's easier. Now, in my estimation, when I know the y-intercept, this was by far easier. But Wayne felt this one's easier. I mean, it's all personal.
I just started with one and stuck with it.
You started with one and stuck with it. That's fine. You can. This one will work all the time. Actually, this one will work all the time, because you could put your x and y in here and then find the b and then put it back in. So you can pick one and stay with it if you'd like. There's not a problem with that. Okay? That one was 52. Then we need to go to 55. (55) says it's going to pass through negative 5, 2, and 7, 2. So we want a line that passes through those 2 points. The first thing we're going to have to do is find the slope. The slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And so we're going to get y sub 2 is 2 minus y sub 1 is 2 over x sub 2 is 7 minus x sub 1, which is a negative 5. Actually, it doesn't matter what the denominator is because 2 minus 2 is going to be 0, right? And 0 divided by anything will equal 0. We would have 12 down there, but that doesn't really matter. So our slope is going to be 0. So then we can put it into whatever equation you want to. If you want to put it in this one, because we have points, we don't actually have the y-intercept, then you may want to use that one. We'd have y minus, and y sub 2 is actually your choice. Now you have to pick one of these 2 points and use the one that you choose. It doesn't matter which one you choose to use. You're going to get the same answer, but you have to pick one. The one without the negative is what I would pick, right? That's what I told you yesterday. If there's one that doesn't have a negative sign, that's the one I would use. So this would be 2 equals 0 times x minus, and it would be 7. Okay, now we'd have y minus 2 equals, when I multiply 0 times anything, what am I going to get? So everything dropped out over there because it's 0 times everything, so that's why we got y equals 2. If this wasn't 0, it was a different number, then we'd have to work it out. It'll take longer. We'd still do the same thing, it'd just take longer because we'd have numbers over here. Okay? But this one was, excuse me, easier because it was 0. Then once you get down here, you pick one of your 2 points. You're going to substitute your slope, and you found you needed both points to find your slope. So you substitute that in, then you pick one of the 2 points. It's easier if you pick one with all positive numbers if it's possible. So that's number 55. Then let's go to 46 next. Okay, number 46 says m equals a negative 13 over 5. And it passes through 3 negative 2/5. Okay. Now, did you use y minus y sub 1 on this one? No, I used the other one. You used the y equals mx plus b? Okay, it's your choice. So let's do it y equals mx plus b. Most of you probably used the other one being you were given a point, but it's your choice. Makes no difference. Okay, so we'd put y is negative 2/5. M is a negative 13/5. X is 3. And we're going to find b. So 2 from 39 is going to give me 37. So b is 37 over 5. So we did a negative 2/5, and this would be a negative 13/5 times 3. So we took 3 times 13, which would be 39. Then we'd have to add 39/5 to both sides to get b by itself. So we'd have b equals 37/5. Now we'd go back into that same equation then and substitute in our 37/5 for b and our negative 13/5 for m. So we're going to go back into this equation, and we'd have y equals, and m is a negative 13/5. And b we just found is positive 37/5. Right? Now we'd go through and put it in standard form. First thing I do is get rid of the fractions. And I'm going to use the distributive property right away and distribute this 5 instead of write it times that side and then distribute the 5. So we'd have 5y equals, and this will cross out, a negative 13x, and this will cross out, plus 37. Standard form means x and y have to be on the same side, so we'd add 13x to both sides. And so we're going to end up with 13x plus 5y equals 37. Okay? Now, if you wanted to put it in the other equation, I was asked to put it in the other equation, so let's do that. It'll be the same thing, only this time we're going to put it in y minus y sub 1 equals m times the quantity x minus x sub 1. So we'd have y minus y sub 1 is a negative 2/5 equals m, which is a negative 13/5, times the quantity x minus x sub 1, which is 3. Okay? And now this will give me y plus 2/5 on this side. And it's up to you. You can multiply out first or get rid of your fractions first. If we multiply first, we get a negative 13/5 x and a plus 39/5. 13/5 times x and then 13/5 times 3. Okay. Then I'd probably subtract 2/5 from both sides first. Or do we want to get rid of fractions first? Get rid of fractions? Okay. 5. Then we take 5, which is the common denominator, times y, plus 5 times 2/5 equals 5 times a negative 13/5 x plus 5 times 39/5. We could have gotten rid of the fractions before we multiplied this out too. That's up to you. So we'd have 5y plus 2 equals a negative 13x plus 39. Now I'll subtract the 2 then. And we'd have 5y equals a negative 13x plus 37. Then add 13x to both sides. And you can do this in any order. It doesn't matter what you do first. All you have to do is end up with x and y on the same side, on the left-hand side when you get all done, and the constant term on the right-hand side by itself. So you could have moved the 13x first, then chosen to move, then you could have chosen to move the negative 2. That's up to you. You could have gotten rid of your fractions right here. We've done that. 5 times this, well, we would change those signs first, but 5 times this one, 5 times this one, and then 5 times this quantity, which would have just left me as a negative 13 times x minus 3. That would be all in your choice. Okay? And now, which way's easier? Some of you are going to say this way's easier, some of you are going to say the other way's easier. The
So
easier
for most of
one,
these, you can do either way. It doesn't matter.
you can do it either way. Yep. It's your choice. Totally your choice which of those two you want to use. Now, if you're looking for the slope, you have to use m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. If you're given 2 points and you're looking for the slope, you have to do that. If you're given an equation and you want to find the slope, you have to put it in slope-intercept form. Okay, so those things you have to do to find the slope, but otherwise it's your choice.
Do we have to show that first step to find the slope, or can we just...
Like yesterday, I just went on my graph here and figured it out, the slope was 0. Just like that.
You graphed it
Yeah.
rather than did it the other way?
Doing your top step up there. Find the slope. On the one that we had, there was 2 different groupings. One had the negative in it.
Okay, so what you're saying is, and I can't even find it, When I was given 2 points and had to find the slope, you just put the 2 points on the line and figured the slope that way? You didn't put it in this form, you put it on the graph?
I did it that way, but first I did it on my graph. It seemed easier just to quickly do it on my graph paper.
Makes no difference to me.
So Jan, which ones?
You're doing the same thing, you're just doing the difference on the graph paper.
Which ones do you have to do that for sure? Can you say that again?
Well, if you're given 2 points, you have to find the slope this way. This is just to find the slope. 2 points, to find the slope, you'd have to use this. If you're given the equation of a line and you want the slope, you'd have to do this. This is to find the slope. Yep. Then after that, you can do whatever you want. But you would have to find the slope. So to find the slope, if you're given 2 points, you'd have to do this, and if you're given an equation of a line, you'd have to do that. If you're given the slope, then you just start right out with it. This is when you don't know the slope. Okay?
Jan, on number 52, I'm still not sure why you negative 3/4 is the slope. I mean, I was thinking it was 3. Why is it 3, negative 3/4?
Okay, I have to find it. 3x plus 4y. The reason I can guess is because you have to solve for y. You can't have what 3 or 4y equals. See, you have to put it in the form y equals mx plus b. This means 1y. And see, in order to get a negative 3, you had a 4y. You can't leave it 4y equals something. You have to solve for y. If you solve for y, your slope's going to be a negative 3/4. That means have y by itself on one side of the equation. What we have to do is solve for y. We have to know what 1y is equal to. So we subtract 3x from both sides, we get this. Then we'd have to divide by 4 to get what y equals. And then that's the slope of the line. Once you've solved for what 1y is equal to. Okay? You have to solve for y. You can't solve for 4y. And see, that's what you did. You said 4y equals a negative 3x minus 9. No.
I just pulled it down.
Yeah. But you would need to solve for y. Once you know what y equals, then this is the slope of the line. Otherwise, it's not the slope. Okay? Now I have one more I have to do. And then I moved all my papers, so now I have to hunt for that. Was it 22, I believe? Am I right that I have 22 left to do? Oh, here it is, right on this paper. It was right in front of my eyes. That's why I couldn't find it. Okay, number 22. Okay, it says slope is a negative 3/7. And it says the point is 1 5/7. And it tells us to use the point slope form. Now on the test I won't tell you to use the point slope form. Like I said, you can do it either way you want to. I don't care, just so you find the answers. If you do the point slope form, that's the y minus y sub 1 equals m times the quantity x minus x sub 1. And point slope form will be told, that will be listed in your book inside the cover. I think it's inside the back cover that we are now, isn't it? Yep, inside the back cover is where chapter 6 is. And the formula for the slope of a line is there, the slope-intercept form of it, the point slope form of an equation, all of those are listed back there for you. So you shouldn't have any problem with that. So if I did use this, then I would go y minus, and y sub 1 would be 5/7 then, equals m, which is a negative 3/7, times x minus x sub 1 is 1. Okay? Now, Travis, I said his name wrong yesterday. Am I wrong again? Travis is right. What do you want to do next? Because it's really your choice again, right? Do you want to get rid of your parentheses first, or do you want to get rid of your denominator first?
Let's get rid of the fraction. Oh, 3x minus, or 3x plus, just go through and do it.
Multiply that first? Okay.
Negative 3x plus 3/7.
It'll be a negative 3/7 x, you mean, plus 3/7. Okay, that's what I needed to know. Do you want to remove the parentheses first or remove the fractions first? So we remove the parentheses first, and that's negative 3/7 times x, and negative 3/7 times a negative 1.
Multiply everything by 7/1.
Yep. Whoops, I was looking at the negative in front of the 3/7, so I put a negative there. Okay, when I do that, I'm going to get 7y, and this will cross out, so it'll be minus 5 equals, this will cross out, and I'll have a negative 3x. This will cross out, and I'll have plus 3.
Oh, I just didn't, the reason I got it wrong, I didn't have a negative in front of the 3/7 up in the second step right there. And so that's
Right
what
there.
made it 2. I had to answer 2 instead of 8.
Okay,
Okay.
yep. One sign error and you're in trouble. What he was telling me is he had a sign wrong, and that's why he had it wrong. Because we have to end up with it in this form, so it's up to you. You don't have to have your steps exactly the same way I have my steps. And like I said, on the test, I won't tell you to do a certain form. You can do whichever one you want.
I have an easy question. Except I missed it, so it must not be that easy. On 37, I thought that if they were going to be perpendicular, they had to be negative.
Yep.
Okay. So why is the second one negative?
37, to be perpendicular, the slopes have to be negative reciprocals. In the first one, the slope is 1. In the second one, it's negative 1. Are they negative reciprocals? What's the reciprocal of 1? That's reciprocal would be 1. And then they have to have opposite signs. How do I know what?
So you can't just look at that and know that you have to work the problem with it, right?
Well, this is the first one, and this is the second one. So they already have it in slope-intercept form, right? So all I have to do is read the slope. The slope of this one's right here, so it's 1. The slope of this one's right here, so it's negative 1. And if I have 1, okay, to make it a fraction, it's 1 over 1. And if I do the reciprocal of 1 over 1, it's going to be 1 over 1, right? Okay, and so the reciprocal is actually 1, and are they negatives? Yep. In other words, they have to have opposite signs. When it says the negative reciprocal, if this one's negative, this one has to be positive. If this one's positive, this one has to be negative. Yep. Any other questions?
Could you do 58, please?
Okay. 58.
And 61.
Okay, 58 says passes through 2, 1. And perpendicular to a line with the slope of negative 3. So this is, but they want it perpendicular to that line.
So you use that y minus y equation then?
Okay. Yep, the first thing we have to do is figure out the slope of a line that's going to be perpendicular to this line. If this line has this slope, in order for it to be perpendicular, the slope's going to have to be what? The reciprocal of 3 is what? 1 over 3. Yep, this one's 3 over 1, so its reciprocal will be 1 over 3. And if I want the negative reciprocal, if this one's negative, then this one's going to be positive, right?
How do you tell that?
If it's perpendicular, they have to be negative reciprocals. A reciprocal of a number, if it's 2/5, its reciprocal is 5/2. If it's 3, to make it a fraction, it'd be 3/1, so its reciprocal is 1/3. And negative reciprocal just means that they have to have opposite signs. Okay? So we'd need the slope of 1/3, and it goes through this point. So it seems like most of you are using this one. Like I said, it's up to you. You can use either of the equations that you want. It's your choice. You can use y = mx plus b and get the right answer also. So it's your choice. Y minus and y sub 1 would be 1 equals 1/3 times the quantity x minus, and x sub 1 would be 2. Now, Brad, I'm assuming you used this formula. Am I correct? I didn't hear what you said.
Yes, you are correct.
Okay. Now, what do you want to do next, Brad? Do you want to remove the parentheses or get rid of the fraction?
Remove the parentheses.
Okay, so we'd have y minus 1 equals 1/3 x minus 2/3. Then I'd remove the fractions next, and common denominator is 3, so take 3 times y, and 3 times 1, and 3 times 1/3 x, and 3 times 2/3. And the signs are going to stay the same as what they were. So we're going to have 3y minus 3 equals, this will cross out and I'll have 1x or x. It's the same as over 1 if you want to do that, and this crosses out and it'll be 2. Now, what should we do? Remember, there are two ways we did this. Do you want to subtract x and then change the signs, or do you want to put everything, the x and y on the right-hand side, and change sides of the equation? That's what you have to decide. Brad, do you have a choice?
I don't know, I just add 3.
Okay, add 3. All right. Then you subtracted 1x, I meant, not 1. Subtract x. That would be my guess if you subtract or added 3. Now you have to change all the signs because x, the coefficient of x cannot be negative. So all we do is change all the signs. X minus 3y equals -1. Basically, we're changing the sign of the 3y, but plus a negative is the same as subtract. So that's why you can change the sign there. You change the sign of the number here, and the letter actually here, and the number here, so why the sign of operation there? It's because plus a negative is going to give you subtract, and you wouldn't write it with both signs. Okay? Then 61. Now on 61 it says has a y-intercept of 0, 3. So you could do slope-intercept form as long as you know it's a y-intercept, and it's perpendicular to the line y equals 1/5 x plus 12. So the slope of this line is 1/5. If we want it perpendicular to that line, what do we want the slope of our line to be?
-5.
Because the reciprocal of 1/5 would be 5, and then we need negative reciprocal, so we need m to be -5. We're going to use 0, 3. Now, I'm not sure who asked me to do this one. Do you want to put it in a slope-intercept form or in that same y minus y sub 1? It's your choice.
Minus y sub 1.
This one?
Yes, please.
Okay. So we would have y minus 3 equals -5 times x minus 0. So y minus 3 equals a -5x. up to you what you do next. Add 3 to both sides first, probably is what most of you would do. And then add 5x to both sides. Because remember, we have to have the x and y on the same side and the number on the opposite side. So we'd have 5x plus y equals 3. Okay? Then we probably need to go on, but you're getting the idea. Remember that if we want the slope to be, we want the lines to be perpendicular, the slopes have to be negative reciprocals. Reciprocal of this would be 5 over 1 that we could write as just 5. Then negative reciprocal means that they have to have opposite signs. So if this one's positive, this one has to be negative. If the first one was negative like our other one on this one, if this one's negative, then this one has to be positive. Reciprocal is just like tipping it over. If it was 2/3 reciprocals, 3/2. If it's 3 reciprocals, 1/3, so on. Okay? That's perpendicular. If we wanted it parallel to the line, then the slopes would stay the same.
For number 61, and then part of it says y equals 1/5 x plus 12. Why do they put all that extra stuff in there if we're not going to use it? Just to confuse us, or what?
To see if you can figure out what the slope of that line is. So see, we had to figure out the slope ourselves. And then to see if you knew how to find that perpendicular is the negative reciprocal. If they would have just given you the slope, then that's easier than. The harder one would have been writing it x plus 5, or x minus 5y equals negative 12, and then tell you to find a line that's perpendicular to that line.
They got like that plus 12 in there. We don't ever use that, I think is what he was asking.
Right. But the thing is can you find what is the slope? And like I said, it would have been more difficult yet if they would have put the equation in general form to begin with. Then you would have had to do everything, meaning you would have had to put it in this form besides read the slope off it. But no, that's their purpose, is to see if you can figure out what the slope is and then take the negative reciprocal of that slope. Now, we're going to skip a couple sections and we're going to go back to 6.6 now on page 387. This is relations and functions. In order to be a relation, there just has to be some kind of relationship between things. If we have an equation, y equals x plus 3, that would be a relation. Okay, a relation can be anything that has a relationship between it. If I have something like a person and their telephone number, let's just make up some people. We'll say Meg and her number is 878-3456, and then we have John and his telephone number is 235. I think that's Menominee's, one of theirs. 3689, and let's have Travis, and Travis's phone number, he doesn't want to give it to us. Is he 723?
I'm not talking to you, Jim. I don't care if you prank me.
And then we have Mary, and her phone number is, what do we need? Neilsville, I have no idea what their extension is. I'm sorry. Oh, you know, don't you? 743-6819. Let's just, okay. Now, that is a relation. It is also a function. Because Meg has one phone number, John has one phone number, Travis has one phone number, Mary has one phone number. This is a relation. It doesn't matter. It's a relation and it's a function. A function is for each x value, domain, there is one and only one y value. Now, if all of a sudden Mary has 2 phone numbers, an office phone, or they have 2 lines coming into their house for some reason, now this is still a relation, but it's no longer a function. Because for this value, there are 2 values over here. Wait, now I said that wrong. That is still a function. No. No, don't do that, you're right. I just blew it.
Which one's the function?
Everything's a relation. Okay, all of them are relations. Some relations are functions, some are not functions. And I just blew it in my own mind. For each x, there can be one and only one y. So this is not a function.
The same of y for x?
Right. Okay, that is not a function because for Mary, she has 2 phone numbers. Now, it would still be a function if we said, let's switch it now. It's not a function if this is like our x or domain. There can't be 2 range values or 2 y values for one of them. But now if I had, we'll keep Meg, we're going to keep them all the same. Meg as 8, 7, 8, 3, 4, 5, 6. And John is 2, 3, 5, 3, 6, 8, 9. And Travis is 7, 2, 3, 1, 1, 6, 9. And Mary can even have her 2 phone numbers, but we'll just give her one just to do it quickly. Now let's say Travis has a roommate, Bruce, I don't care. And so if he has a roommate called Bruce or Dawn, it's his choice, right? And he has the same phone number, that's still a function. Because Travis still only has 1 phone number, Bruce still only has 1 phone number. So that would be a function. Because for each x, there is one and only one y. Okay? So that's how you can tell functions and relations. All of them are relations, by the way. Anytime there's any relationship between them, they're a relation. But a special relation is a function then, basically. Yep. So it's still a relation even if it is a function. Now, anytime we have a line, a linear equation, one that you can graph and you're going to get a straight line, that's going to be a function. Because for each value of x, there can only be one value of y, right? Because if I put a value in there for x, how many y's am I going to get? 1. So that's going to be a function. Now, if I have a quadratic equation, they're not all going to be functions. Oh yeah, all functions are relations. Yep. But now if I have a quadratic equation, they're not all going to be functions. If we are squaring the x value, we're not going to have a problem. If we have a quadratic equation that says something like y equals 2x squared plus 3, that's still going to be a function. Yep.
Wouldn't y have to be squared too, though?
Nope. Now, if I have a quadratic equation that gives me y squared, x equals y squared minus 3, whatever it happens to be, then this is not a function. They are all relations, but this one would still be a function. This one is not a function.
So in order to be a function, y can only equal what x is.
X can be equal, yeah. There can, for each x, there can be one and only one y value. It's basically what it is. For each x value, there can be one and only one y value.
And that's a function.
And then it's a function. Everything's a relation. And there's nothing wrong with relations either. This is going to give me a, if I wanted to graph it, I could graph this also as easily as I could graph this. It's just that this is a function, this one is not. That's all there is to it. There's nothing wrong with a relation. It's just that some of them are functions and some of them are not. And in order to be a function for each x value, there can be one and only one y value. Now, if there's two different x values and they have the same y value, that's okay.
X value doesn't have nothing to do with the function.
So if I listed ordered pairs and I said whoops, I don't want it. Well, now that I've done it, I'll leave it that way. Is that a function? No, because for 2, there are two different y values, so it's not a function. Okay, for each x, there can be one and only one y value. So if I had 2 with a 3 and 2 with a 6, then for that x value, there are two different y values, then it's not a function. Okay?
Do they have to be, both of them have to be 2 and 3?
Yep, it can only be there once, actually. 2 can only show up once.
Up above there, your 2 is your x, right?
Yep. These are ordered pairs, so x always is first. Okay? X is always first in an ordered pair. So these are ordered pairs x, y. Is this one a function? Yep, because for each x there is one and only one y. Now, for this x, the y is 3, and for this x, the y is 3, but that doesn't matter, because for each x there is one and only one y. You see that none of the x values are shown twice, then you're okay. If one of the x values is twice, then it's not a function. Okay? So this one is not a function up on top. This one on the bottom is a function. They are all relations. Now, when we're talking about the x value, that is called the domain. The x value is the domain. And basically here, the x value is also the independent variable. That's how we're using it. So in ours, the x value will be the domain and the independent variable. The y value then is called the range. So when they ask you for domain and range, you know what they're talking about. The range was the y value, and that's the dependent variable. In other words, y depends upon what we choose for x. If we graph it, it's easy to tell whether it's a function or not. If you have something graphed, you draw a vertical line. If it touches it or cuts it only once, then it's a function. If it cuts it more than once, it's not. So that's when I do the quadratic equations. If they look like this, it's only going to touch it once. Okay, this should be keep coming out this direction, not go in. If it looks like this, which is what happens on the others, then it's going to cut it twice. And that's why it's not a function. That's how you can tell. So if you draw a straight line, you can tell. Now,
Jan, did you say if it only goes through it once, it's considered a function?
yes. And if it goes through it more than once, when you draw a line anywhere along it, it doesn't have to be that side, it can be any place. If it cuts it or goes through it more than one time, then it's not a function. So that's what they call their straight line method of figuring out if it's a function or not. As far as domain and range are concerned, as on the problems they're giving us, the domain is always going to be all real numbers. We're talking about the real number system, and the ones that they're giving us, the domain is always all the real numbers. And then what you're going to have to do is look at the relationship they're giving you and decide why the range can be then. If the domain is all real numbers, look at each situation and decide what the range actually can be. Now, the domain is not always going to be all real numbers. They're just giving you the ones that are for some reason. If there's a fraction, it's not going to be real numbers, okay? If it's a fraction, with if we would have the something like, I don't know. Now x can't be 0 because I can't divide by 0. Then that domain would not be all real numbers. But they didn't give us any like that, okay? And the other thing is, if I have a square root, I don't care what. We can't take the square root of a negative number, so then that would limit the domain. But those are the two things that would limit the domain, okay? In this case, they didn't give us any with the denominator. They didn't give us any square root, so we don't have to worry about it. And what I didn't get to is just substituting in for functions, but you've done that already, haven't you? Substituted values in? And that's what the rest of this is. If you look at number 17, it says f of x equals 3x, and up in the instructions it says a find f of 3, so then you just do f of x. You do f of 3 equals 3 times 3. Just substitute in the value for all of those. So then your assignment, we're going to start with, this is on page 391, and we'll start with number 2 and go through 40 even, and then we're going to go skip down to 50 and do 50 and what? Let's do one other one, 50 and 54. No, I don't want to do 54.
55.
Let's see. All right, we're going to do 49 and 50. I'm doing none of them with letters. I wanted two numbers, and I guess 49 and 50 are the only two with numbers, aren't they? So 2 through 40 even, 49 and 50. Okay? And then I will see you on Monday. Have a nice weekend. Your tests went out yesterday, so they should be there on Monday. We should have a 2-hour class on Friday. Nobody comes in after us. We could stay here for 2 hours. And then you wouldn't have to show up a different day. But if I did that, then I would have like 5 hours in a row, and I might not like that. So maybe I'll just be quiet. Yeah. When I should cut the questions off a little bit sooner so that I don't hard to know what to do, because sometimes it just clicks once you We're going to take a new sheet of paper to make sure that we have room. 43 is probably going to give me problems anyway, because I'm not going to be able to show you the whole problem at once, am I? Then the next one says, which one am I doing now? 43, thank you. Subtract, and then we have the quantity 4x squared minus 3x plus 2. Okay, let's just work with those two first. If I did, these have parentheses preceded by no sign, which means it's plus, so when I drop those, the signs of everything inside are going to stay the same. Now this one is preceded by a negative sign, so that means the signs are going to change. This is going to be subtract 4x squared. This one's going to be plus 3x, and this one's going to be subtract 2.
Couldn't you put plus a negative x squared?
Plus a negative 4x squared? Yes, you could. Yep, you can put plus a negative if you want to. You could put plus a negative 2 also if you want to. And then the last one that I hadn't copied yet.
The first set, isn't that supposed to be plus 1?
What do I have? Ooh, 43 I'm doing. And where did I get my negative 2 from? 39. Do I have the second one copied right, or did I copy part of 39? Okay. Yes, you are right. Thank you. Sorry, my eyes went up to, because the negative 3x is the same, I caught 39. This should be plus 1. Sorry about that. That should be plus 1. Thank you. Now this last one says plus, and then in parentheses, 2x squared plus 3x plus 2. And I remove the parentheses preceded by the plus sign. Everything's going to stay the same. And now you just combine like terms just like before. So I'd have 2x squared, a negative 4x squared, and 2x squared, right? This you can write as plus a negative if you want to, like you asked. That would be fine. They're going to add up to 0, aren't they? Okay, that's all right. We don't care. Then we're going to combine this one, and that one. These two will add up to 0, plus 3x will give me 3x. Is that right? A negative 3x, remember this is plus a negative, so that's a negative 3x plus 3x would be 0. 0 plus 3x would be 3x. And now we have this one, and this one to do. And these two are going to add up to 0, aren't they? So I'm going to have plus 1. Because you can add it in any order. So when I noticed that those two had opposite signs but were the same, I did those first and got 0 and then added 1 onto that. So our answer would be 3x plus 1. Okay? And you can always change these to plus a negative if it's easier for you.
We do 61.
Well, I do 61. He wants to do a hard one, huh? Okay, now in these, what's the problem is? The sign in front of them goes with them again. And it says to subtract this. So it's the same as if this second group has a parentheses with a negative in front of it. So the first thing I have to do is go through and change all the signs of the subtrahend, which would be the second group here, because it said subtract. Now if it says add, I leave them exactly the way they are. If it says subtract, that means I have to change this one, and this one. Now you add them just like you would before. You can start on either side. I usually start, well, here it doesn't matter. Negative 2 and negative 10 would give me a negative 12, x squared, y squared. A negative 4 and a negative 9 gives me a negative 13, xy. positive 12, positive 24 gives me 36y squared. It would,
If it's saying subtract, why are we adding? Like your 12y and your 24y?
if they have like signs, we add them and keep the common sign. We don't know how to subtract. That's why we change it all to addition. That's why we change these signs, because now it's add. Once I change the signs of that second one, then we do proceed as in addition of sign numbers, which says if they have like signs, you add them and keep the common sign. If they have unlike signs, you change them and or find the difference between them and keep the sign of the one at the larger absolute value. See, when it said subtract up there, it would be the same as this if it were written the other way. It's this, subtract this. Whoops, I'm sorry, this didn't have a negative. So it'd be minus and then what's in the book to begin with. So if it's add, you leave the second line alone. If it's subtract, you change the signs of everything in the second line. Okay? So it'd means the same thing when it's written like this. It's the same as doing it when it's written like that. Okay? Now I'm going to have to give you your assignment because we have 1 minute left according to what time I have here. So let's start on page 179. You've done the other stuff, so I'm just going to have you start on page 179 with number 32. And go through, let's just go through 68 even right now. We'll look at the other ones tomorrow. 32 through 68 even. Okay?
Say, Jan, we have a question.
Okay.
For the last test, we didn't, us and Chippewa, at least two of us took our test in Chippewa and we didn't hand in our assignments. Can we still hand them in?
Sure. No problem.
This power times this power would be b to the 18th. Okay?
So like on number 66 where there's s squared raised to the third power, and then again, or, you know.
Right, go down the line. What's s squared raised to the third power? Another way of writing that.
S5?
Nope. You're multiplying now. A power raised to a power, you multiply. If you take the product of two powers, you add. Right? So that's s to the 6th. Now s to the 6th, now you look at the next one, s to the third times, or raised to the second power is what? X to the 6th. S to the 6th times s to the 6th is? No. Now you're adding. Here we have this. Right? This here becomes s to the 6th. This becomes s to the 6th. Now you're going to multiply these together. If the bases are the same, what can you do with the exponents? Add them. So that comes out to be s to the 12th. Okay? And then you're going to end up with that. Now this is also s to times s to the 4th all to the 4th power. So what's s to the 4th times s to the 4th? S to the 16th. So now you got s to the 12th times s to the 16th. What are you going to do? Add them. You get s to the 28th. Now, so make sure you go through on page 153 is the first rule of exponents. Right in the middle of the page. You're going to multiply two exponents, exponential numbers whose bases are the same. You add them. Right? The second rule for exponential numbers, page 154, a product raised to a power. That's what this one was, s to the 3rd squared. Power raised to a power. You multiply them. Right? And the Third rule is on the middle of page 155. If you have a product of two numbers whose bases, they're not the same now, if you raise those to a power, you can write that then as x to the nth times y to the nth. A product raised to a power is the same thing as the product of the powers, a product of the exponential numbers. So that's the third rule. The fourth rule is on page 156, and that dealt with quotients. X to the n divided by x to the m. And then you subtract the power that's in the denominator from the power that's in the numerator. That's what they're doing here. There's nothing to say you can't do it reverse. You can.
Well, Monday's another day, so.
Okay. All right. Have a good weekend.
Yeah,
all right?
You're
And hopefully I'll become accustomed to what's going on in here and see what happens. It's not too bad. Yeah. I'm used to working on a chalkboard, starting in that corner and going all the way across. So staying confined to a piece of paper is kind of hard.
Can you call you Mr. Dyke?
That's fine. You also. Oh, correct. That's what he said. He told me that.
But I would just make a little extension on it.
You should. Pardon?
My test and my homework are done.
Okay, fine.
Thank you.
Mm-hmm.
Diagram that I was just using in the textbook, and it is in, let me just show you the textbook. Page 240, you said?
242. 242.
I'll find it. It's in page 242. Oh, there we go. Okay. A little more detailed. There's more stuff there, but... Okay. So... if you need to refer to it again, 242 in the textbook by Brand, okay, Oral Anatomy. Okay, all right. Does anybody need, do you want to take a break now or do you just want to go on? Who wants to take a break? Nobody wants to take a break. Everybody wants to get out early.
You want to get done early?
Want to get done early. If you need to leave and get a drink, just go ahead. I mean, that's fine. But if you want to get done early, then we'll just go ahead and keep going, if that's all right with everybody. Any questions, just holler, okay?
What was the pulp cavity again?
Okay, let me just get, it was asked which part was the pulp cavity? Right, the pulp cavity is the whole thing. The whole thing is the pulp cavity, the whole pulp. Sometimes it's just referred to as the pulp. The pulp cavity is the whole thing. Then they divide it into the top, which is the chamber, and the bottom, the long things that go down into the, actually into the, towards the end of the tooth, as the canal, okay? So the whole thing is called the pulp cavity. Then it's divided pulp chamber, pulp canal, and pulp horn, okay? These pulp horns, as a person gets older, they tend to flatten out. I don't know why you need to know that, but it's just a little one of my notes here, okay? It's just a good thing to know, okay? Let's go on to anatomical crown. Oh, this is much. Clinical crown versus the anatomical crown. Looks like a fight there, doesn't it? Okay, I have a pretty good, what I think is a pretty good overhead for that. Clinical crown, actually I'd like to do the anatomical crown first, okay? The anatomical crown is the part of the crown that's covered by the enamel. If You can see me outlining this. Can you see that outline? You want me to maybe? Can you? Okay. No, no. It's the part of the. I can show it over here too. This is the clinical crown right here, the part that's covered with enamel. I mean, I'm sorry. This is the anatomical crown, the part that's covered with the enamel. That's the anatomy of the tooth. The crown of the tooth, the anatomy of it is made up of enamel, covered by enamel, okay? When we get into clinical crown, which that means what we can see clinically. Now, if you can see more, if you have the gum tissue, what we call receding way down here on the root, that is considered the clinical crown. Not the anatomical crown, but the clinical crown. Okay? This is also the anatomical and the clinical crown. Okay? Does that make sense? A little bit? Question?
This is Michelle.
Hi, Michelle.
So some of the clinical crown might not be covered by enamel?
Some of the clinical crown might not be covered by enamel, she asked. Yes. Some of the clinical crown might be covered by some